All right, then let's just get started right away then.
Okay.
The first problem in parentheses, 5 minus x, close parentheses, e to the x.
That?
Yep.
What do each of these stand for?
Let's see, log, inverse trig, polynomial, exponent, and then trig again.
Yeah, this is the priority for u.
Right.
So what are we going to let u equal here?
5 minus x.
And what are we going to let dv equal? Everything else.
Yeah, e to the x dx.
Okay. And since the integral of u dv is equal to uv minus the integral of v du, we're going to need a v, and we're going to need a du. So let's get the du first. How do I get du? Differentiate the left to get du dx.
Okay.
What's that equal to? Apply the power rule to differentiate both of these terms.
Let's see. So that would be negative dx.
Negative 1 is du dx, which means du is negative dx. Okay, what's v?
E to the x.
In other words, I could rewrite the right side like this. I could divide both sides by dx, so I've got dv dx is equal to e to the x. Now if I integrate both sides of this equation, I get v equals the integral of e to the x, which is e to the x. So now, plugging in, what do I end up with?
Let's see. So that is 5 minus x e to the x minus the integral of e to the x times negative dx.
Right. So it turns that into a positive, like that. Okay. So what's the final answer?
5 minus x e to the x plus e to the x dx.
Once you evaluate that, in other words, once we find the antiderivative for e to the x, we lose the integral sign and we lose this differential.
Okay.
Okay, so it's really plus e to the x plus c.
Okay.
So that's what the integral of this is equal to. And we can simplify that by factoring out an e to the x. What else? What's left over when I factor out an e to the x?
5 minus x plus 1.
So now it simplifies to
Okay.
Okay? You can just hold off this c until you get to the end and add it, because
Okay.
it might be a different c after I factor out an e to the x, but it's still going to be a constant.
Okay then.
Okay, let's go back to this step so that we always have this limit to refer to. Now, I've also seen in calculus books where instead of lipit, it's log poet. Very similar. First, look for logs. They don't have any inverse trig functions in log poet, so the next would be polynomials. The PO is polynomials, the E is exponentials, the T is trig functions. But lipit actually is a little bit better because lipit has an I in there. In other words, if there are inverse trig functions in the function, then that I is significant. So lipit actually is a little better than log poet. I'm surprised they haven't given you one of the two.
Yeah.
Although I have seen books that focus more on what you want to let dv equal than what you want to let u equal. There are some functions like secant cubed where it makes more sense to figure out what dv should be. And what dv should be is whatever integrates the easiest. Notice that dv, I would let it equal be secant x dx, and I would let u be secant squared. And the reason I would do that is because this integrates very nicely. Only I got it backwards. This should be secant squared here, and that should be secant, because the integral of secant squared is tangent. But probably, I don't know, I think only tougher problems, tougher integrals require you to try to figure out what dv is first. Most of the integrals you're going to run into probably work best if you try to figure out what u is, and figuring out what u is, use that for priority. Okay, you got another one?
Yeah. In parentheses, x squared minus 9, close parentheses, e to the 2x.
Okay, help me out.
So x squared minus 9 should be our u?
Correct, because that's the polynomial.
dv is e to the 2x.
E to the 2x dx. In other words, everything else is that. And we need that dx because you cannot have an equation with one differential in it. Differentials go in pairs. You cannot have a dv all by itself. You can't have a dx all by itself. So if you're going to have an equation with a differential in it, you have to have two of them.
Okay.
Okay, so what's the next step?
Alright, so du, let's see, which would be,
Just apply the power rule
to the left side.
to this.
Oh, so du dx is 2x.
Which makes du equal 2x dx. Right? What's the formula for the integral of a product? In other words, we're looking at the integral of v du is equal to what?
uv minus the integral of v du.
Okay. Well, we've got a du. We need what else next?
U, which would equal...
Well, we got u already. U is that. Du is that. So now we need, we know dv, the only thing left is v.
V, which is e to the 2x.
Not quite. What's the antiderivative of e to the 2x?
2e to the 2x?
It's e to the 2x divided by the derivative of the inside, which is 2.
Okay.
Okay. So what is uv minus v du?
That's x squared minus 9 times e to the 2x over 2 minus the derivative of...
The integral.
Yes, sorry. The integral of e to the 2x over 2 times 2x dx.
Okay. So what is that integral?
Let's see. So
Notice that we need to do it again. In other words, is all we did with our first iteration was take this x squared minus 9 down to a 2x. So we still have an integral that we can't solve directly. We have to use integration by parts again. Let's take that 1/2. Well, these 2's cancel. So I really have e to the 2x times x dx. Right? That's what this equals. In other words, this 2 cancels with that 2.
okay.
Okay. Now we got to do it again.
Oh, okay. So then it's minus or... Oh, okay. So now u is e to the 2x.
Lip it. First logs. P comes before E in lip it.
Oh, okay. So is it just x?
Correct. And dv is... That's why I'm surprised they haven't taught you that, because it's pretty critical.
Yeah.
To know the priority of what to make u. So dv is what?
E to the 2x.
Dx.
Right.
Remember, dv is everything else. So what next?
Let's see. Du dx is 1, which makes du equal to dx.
Okay.
And v is equal to e to the 2x.
What would the derivative of e to the 2x be?
Oh, e to the 2x over 2.
Okay. So now we got x squared minus 9 e to the 2x over 2 minus, now remember where I said the hardest part is keeping track of your negative signs? I'm using brackets because I have to translate this into uv minus the integral of v du. So what goes in these brackets?
Oh, okay, so the inside the bracket is the, let's see, x times e to the 2x over 2 minus the integral of e to the 2x over 2 times dx.
Very good. Okay. Now we know how to do that integral. So what is that integral?
Well, okay, so that is
If it helps, you can remove that 2 by taking it outside the integral as a 1/2.
Alright, so the integral of e to the 2x is that still e to the 2x?
Over?
2?
Yes. In other words, whenever you have e to the cx, the antiderivative of it is e to the cx divided by c. So whatever this coefficient is, you're always going to divide it by that. Okay? So now I can replace what I have circled here with e to the 2x divided by 4. You see that?
Yeah.
Because there's this 1/2 over here. So let's do that rather than me writing everything over again. Let me replace that with e to the 2x over 4. Now we're ready to handle all of our negative signs. So let's remove the brackets. What happens when I remove this bracket here?
That
This bracket here.
positive.
This one turns positive. Okay. Now, what else can I do at this point? Rather than giving this as a final answer,
you can simplify it?
which involves what? What's the first step of simplification? Factoring. There's always going to be a quantity that can be factored out of most every expression here. What's the greatest common factor I can pull out?
E to the 2x over 2?
Correct. Leaving behind what's the middle term?
Minus 1.
Just x. If I take out the e to the 2x over 2, I'm left with x. And the third term?
1/2.
Now we can questioning whether the next step makes sense or not. In other words, does it make sense to combine the minus 9 and the 1/2 and make that read x squared minus x minus 8 1/2? all times e to the 2x over 2.
Can you break the parenthesis like that?
Yeah, this parenthesis here, yeah, I put that there mainly just for illustration. It doesn't have any effect on solving this. I can remove that inside parentheses. It's not like this is being subtracted from something where I would have to distribute that negative sign to both terms. In other words, if it's the first part of my expression, I don't need those parentheses. But I need the second parentheses. I don't really like this 8.5. I suppose I could multiply both sides by, I could multiply the inside by 2 and divide the outside by 2. And that'll get rid of the 8.5. What I'm suggesting is that we multiply the inside by 2 and divide it by 2.
Okay.
And that's going to give me e squared over 4 times 2x squared minus 2x minus 17. Much prettier answer.
Yeah.
Now, I'm not sure you'll get this, but there is a particularly interesting thing that happens when you do integration by parts that I at least want to tell you about because it's so cool. Let's say I had this. And after using the formula, I come up with, I'm just going to make up numbers here because I'm just trying to illustrate a point. There are certain kinds of functions where after the first iteration you end up with something like this. Any idea what you would do at this point here?
Now.
This is very clever. You've probably never seen this done in math before. In other words, it looks like we're stymied, right?
Right.
Because another iteration isn't going to help. I still don't know how to integrate that. But notice that is the same as what we started with. And I can treat it algebraically by adding the integral of this to both sides of the equation, giving me 2 of these is now equal to this term right there. Now dividing both sides by 2 gives me my answer. How cool is that?
Wow, that is cool.
Isn't that cool? Yeah, and that is something that if they make it complicated enough, and usually what it involves is sine x e to the x, something like that, where you do 2 iterations. After the second iteration, the last part of it is sine x e to the x. And that's where you use this technique.
Okay.
You may or may not have any that require that process.
Okay. 1 second. I just got to run to the bathroom real quick.
Okay.
Be right back.
Uh-huh. Highlands Ranch Library.
Here is Highlands Ranch Library.
Okay, I'm back.
Okay.
So the next integral is in parentheses 3x minus 7 times 4 to the x dx.
Like this?
3x minus 7 times 4 to the x.
What's u?
U is 3x minus 7.
dv?
4 to the x.
Okay.
Du is 3 dx.
Yeah, you can skip that step. You know, once you get comfortable with doing this, you don't need to write du dx as 3. You can go straight to du as 3 dx. Just like I don't need to rewrite this as dv dx is equal to 4 to the x. Let's just integrate it. In other words, what I'm really doing is taking the integral of both sides. Right? If I take the integral of just dv, I get v.
Okay.
And what is the integral of 4 to the x? Here's the formula. It's 1 over the natural log of a times a to the u.
So that'd be 1 over ln of 4 times 4 to the x.
Correct. In other words, it's the same as integrating e to the x. In other words, you still get 4 to the x, but now you have to divide by the natural log of whatever this number is. Notice that if it was e to the x, what's the natural log of e?
E to the x? Or
No, what's the natural log of e equal to?
1?
Yes. In other words, we could apply this to everything including e to the x. It's just that the natural log of e turns out to be 1, so it's just e to the x. But if there's a number there, then you got to use this. Okay. So our expression is now equal to what?
uv minus the integral of v du, so that's 3x minus 7 times 1 over ln of 4 times 4 to the x minus the integral of 1 over ln of 4 times 4 to the x times u to the x dx.
Okay, it's uv minus the integral of v du. And I like to think of it as voodoo. I always remember it if I think voodoo. The integral of voodoo, which is the integral of v du. Well, this is v. What's du?
Oh, that's 3dx.
Okay. Let's simplify that, or let's evaluate that. It's probably easier to evaluate if you take all of the constants outside the integral sign. So what are the constants in that expression?
3.
What is natural log of 4? Is that a number?
I'm not sure.
Yeah, it is. If you can look it up in your calculator, it's just a number.
Okay.
Okay.
1.38 or through 1.39.
We don't need to turn it into a number. We just
okay.
need to recognize that that's no different than the number 3 in terms of being a constant, allowing me to take it outside the integral.
Okay.
I can't take this 4 outside the integral because it's being raised to the x power. But this 3 is a constant and this natural log of 4 is a constant. So I can remove both of them from the integral.
Okay.
Okay. Now, what's the antiderivative of 4 to the x?
That would be 1 over ln of 4 times 4 to the x.
Simplify.
Alright, so that's do I multiply the two functions on the right together?
No, probably you don't want to do that. It'll just make it harder to factor. Remember, the next step is always to factor out the greatest common factor. What's the greatest common factor between that expression and that expression?
4 to the x over ln of 4.
Now what's left?
3x minus 7 times 3dx.
Minus.
Oh.
And there's no more dx. Remember, we've already taken the integral of it. So we've gotten rid of all the differentials. So if I factor out a 4 to the x over natural log of 4, what am I left with? 3 over natural log of 4. And this is an acceptable answer. In other words, we don't actually have to turn that into a number. We can express it exactly like we did. In fact, it's better to express it this way. Because if you turn natural log of 4 into a number, the best you can do is approximate it.
Right.
Natural log of 4 is the precise answer. Any decimal number that I put in there is an approximation. So I don't want to combine the number 7 with whatever number that is.
Right.
Okay, so this is the best way to leave the final answer. Okay. Pretty much the method is the same every time. And that's the key to doing these. That's why lipid is so important. If you took away lipid from me, I wouldn't know how to do these.
Right.
I mean, it would be a lot harder.
Yeah.
And I'm not sure that lipid's going to work 100% of the time. But it'll work 100% of the problems that you're going to be faced with. it's probably possible to find a function that lipit would not be the best way to go.
Okay.
But it would be rare.
Right.
One of my books talks about log poet, the other talks about lipit. And the third one focuses more on what to make DV, but I find that much harder. To me, it's much easier if you decide what to make U, and then DV is everything else.
Okay. All right, then. Well, then the next one is the integral of x squared ln of x dx.
What's U?
Ln of x.
DV?
X squared dx.
DU? It's the derivative of natural log of x.
Isn't it 1 over the natural log of that?
It's 1 over x. It's 1 over x. In other words, du dx is 1 over x, which makes du equal to dx over x. What's v equal to? Remember, you're always going to differentiate the left side, and you're always going to integrate the right side.
Okay.
You want the antiderivative of x squared.
Oh, x cubed over 3.
Okay? Now what is uv minus the integral of v du?
Okay, so that's ln of x times x cubed over 3.
Okay, and I'm going to put that in front because it's confusing if I write x cubed over 3 to the right of the natural log. I don't want to write this because that's very confusing when you look at it. So put the polynomial part in front, not afterwards. Okay? That's uv.
Minus the integral of x cubed over 3 times dx over x.
Okay? So now we got, what's this after I remove the integral?
That would be...
Always think power rule as the first thing you're going to try. Can you use the power rule to find the integral of this?
I think so.
And if you can, just do it step by step. Add 1 to the exponent and divide by the new exponent.
So x to the 4th over 4?
Well, over 4 times 3.
Okay.
And I still have, excuse me, let me back up a step. I forgot to reduce this. In other words, that x cubed over x reduces to an x squared. Then when you take the integral of it, it's x cubed over 12. You see that? I forgot to do this. So I'm really taking the antiderivative of, it's not x cubed over 12, it's x cubed over 9. You see how I got that? When I took the integral of that, I get x cubed over 9.
Mm-hmm.
Okay. And the final step.
Factor.
Mm-hmm. It's the greatest common factor.
X cubed over 3.
Leaving
Ln of x minus 1/3.
and there's your answer.
Okay, that wasn't that hard.
No, they're all of them, if you follow that methodology, they're not hard. It's just step 1, step 2, step 3, and so forth until you get to the end.
Right.
And it doesn't really matter if you have to do 2 iterations or 3 iterations or 5 iterations. It doesn't look like they're giving you any that you have to do 5 iterations or anything like that. The most complicated thing probably would be that situation that I described, where you get the integral of something and you end up getting it again on the right side. And then you just have to add one of these to both sides. But so far we have not seen a problem that gives us that. So you may not need to know that little trick.
Okay. Well, then the next thing, I guess we'll shift away from integrals,
Okay.
would be finding the area bounded by the curve.
Okay.
And in this case, the problem is find the area bounded by the curve y equals x times e to the negative x. And the x-axis and the lines x equals 0 and x equals 7.
So if I knew how to draw that function, it doesn't really matter whether I do or not, I'm going to draw it like this.
Right.
When they say find the area under that curve, what do I need to do?
If I'm not mistaken, you take the integral of the function from the upper limit to the lower limit.
From the lower limit to the upper limit.
Oh, right.
So it would be the integral from 0 to 7 of f of x dx, which in this case is x e to the minus x dx. So now we have the same problems we've been doing for a bit now. We have to use integration by parts to solve that integral.
Okay.
And the reason we know we do is because we have a polynomial times a transcendental function. So right off the get-go, we see that we have algebraic expression, the product of two functions. And whenever you're looking at the product of two functions, especially if one is polynomial and the other is transcendental, you usually need to use integration by parts.
Okay.
Okay? So, you want to go through that or you want to go to the next problem? In other words, so our problem now becomes this. And I'm perfectly happy to go through another integration by parts if you want to go through that.
Sure, we can just do that.
Okay?
Okay, so my u, would that be e to the negative x?
Lipit. What's the E stand for in Lipit?
Exponent?
Exponential expression.
Right.
This is the exponential expression. X is the polynomial. Since the polynomial comes before the E, then I need to let U equal X.
Okay.
Based strictly on this. U is X, what's dV?
E to the negative x?
Dx.
Right.
Okay? What's du?
dx.
What's v?
E to the negative x.
Divided by -1. Remember, if there is a coefficient in front of the x on an e to the x, then the antiderivative is e to the minus x, the same thing, divided by that coefficient.
Okay.
Which makes it minus e to the minus x.
All right.
So now what?
So that is x times e to the negative x over -1.
Okay, so let's write that. Let's put the negative sign out in front. Make it look like this. That's uv.
Uh-huh.
What's the rest of it?
Let's see, minus the integral of,
Voodoo,
right,
which is v du.
minus the integral of e to the negative x over -1 times e to the negative x.
Right, that's negative e to the negative x. In other words, we don't need to carry that divided by -1 forward. It just makes the whole thing negative. In other words, if I say 4 divided by -1, that's -4.
Right.
Okay? In this case, it was e to the negative x divided by -1, which is minus e to the minus x. Okay? I can take this before I attempt to find the antiderivative of this. Let's take this negative sign out. In other words, I just took a -1 out. So let's evaluate this. What's the integral of e to the minus x?
That is e to the minus x over -1.
Okay, which is the same as,
And negative e to the negative x.
okay, so that's our answer, almost. What's the next step?
Factoring.
Okay,
So we can take out the e to the negative x.
yeah, we might even want to take out a negative e to the negative x.
Right.
That's really the greatest common factor. What's left?
Negative x? Or just
Just
x?
x. What about over here? Notice that this is the same as that.
Yep.
Make sure that you change that sign inside there. It's real easy to leave that minus. But since I factored out a -1, that has to be +1. So now I'm supposed to evaluate it from 0 to 7.
Right.
So let's do that. Leave everything as a function of e. Let's not turn it into a number.
Okay. So that is
Just plug in 7 for x,
Negative.
wherever you see it.
so just negative e to the -7 times -6.
When I plug in 7 for x, what's in the
Oh,
parentheses?
hey, hey.
Minus, because we have to evaluate the lower end of it.
Huh?
And always use parentheses here.
What?
Always use parentheses here, otherwise you're going to lose track of that minus sign.
Okay.
In other words, to evaluate the lower limit, what goes in here?
Negative e to negative 0
Which is what number?
is 1.
Times what?
Times, yeah, just 1.
So now my final answer is minus 8e to the minus 7 minus 1. This was one of the few times we've seen where there is nothing to factor out, because this ended up being the number 1, which is rare because it's only going to be 1 when one of those limits is 0. Otherwise, we'd be factoring out an e to some power. And this is the way you want to put your final answer. You don't want to give it as a number unless it's a multiple choice or something. But I'm betting that even if this was a multiple choice question, this would be the answer. They would not turn this into a number.
Okay.
At least that's my belief on it. I suppose teachers might. There's some teachers that are always going to want you to turn it into a number, even though it's really not the correct way to do it.
Okay.
Okay, what else you got?
Similar question, but you don't have the lines. It's just find the area of the indicated region enclosed by y equals negative x and y equals x to the 4th.
If we graph that, most important thing we need to know is which function is on top.
I'd imagine x to the 4th.
Well, let's take a look. What does x to the 4th look like? Something like this. And what does y equal negative x look like? Something like that. So they want this area right here, presumably.
Okay.
So it's the integral of what minus what?
Negative x minus x to the 4th.
Notice that the top function was actually the y equal negative x.
Right.
And that's very much different than x to the 4th minus the second function. In other words, whenever you're finding the area between two functions, you have to know which one is above and which one is below.
Okay.
Otherwise, you'll get a negative answer. In other words, if the answer was 15, you'd end up with negative 15 if you reverse these. So
from there, it's just finding the integral?
that's pretty easy to find the integral, because the integral of the difference of polynomials is just the difference of the integrals. So we can integrate each of these terms by itself. However, what are our limits of integration?
The area.
We need that x-coordinate and we need that x-coordinate.
Right.
How do I find those?
I'm not sure.
Well, if they're intersecting right here, they only intersect when this is equal to that.
Oh, so we set them equal?
Yeah, we're going to set x to the fourth equal to negative x. Where does that occur? How do we solve this?
Let's see. We could divide both sides by x.
Believe it or not, you can't do that.
Huh.
The reason being is that since x could possibly be 0, if you're going to divide both sides by x and 0 is a solution, you're going to lose it by doing that.
Okay.
So the way you always want to solve these is move this to the other side and factor. In other words, it becomes x to the fourth plus x equals 0. And now solve that. And that way you won't lose the solution x equals 0. Now how do we solve this?
Factor.
Okay. Times what?
X cubed plus 1.
What are my two solutions?
0 and negative 1.
If x cubed, plus 1 is equal to 0, then x is equal to negative 1, and x is equal to negative 1. So here's my two solutions, which represent this point here is x equal negative 1. This point here is x equals 0. So what are my limits of integration going to be?
0 and negative 1.
Negative 1 to 0. Always go from left to right.
Right.
And the lower limit of integration is that point. The upper limit is that point. And again, if you reverse these, you're going to get a negative answer instead of a positive answer. So if you find yourself doing areas between two functions and you come up with a negative answer, you know you've merely gotten it reversed. And in fact, what you can normally do is just change that negative answer to a positive and you'll have the answer.
Okay.
In other words, if I did this from 0 to negative 1, I would get the negative of what I'm going to get doing it from negative 1 to 0. Just like if I put the wrong function on top, I'm going to get the negative of what I would have gotten. So if you get negative areas, because you can't have negative areas, then it merely means you got something reversed, either the limits of integration or the top function.
Okay.
Okay, so that's solved for our limits of integration. Now let's make sure you can do this integral and evaluate it.
So the integral of negative x would be negative x squared over 2. And then negative x to the fourth would be negative x to the fifth over 5.
Okay, let's keep going.
Okay, so then just plugging in the 0 and the negative 1.
Okay, so tell me what to write next.
0 minus 0.
I put brackets to avoid using a whole bunch of nested parentheses.
Right.
If I'm going to have nested parentheses, I'd rather use a bracket. It's much less likely to make a mistake.
Okay. So then it would be 1/2.
When I plug in negative 1, what does this term become? Remember, that squared is not applied to that negative sign. There's no parentheses around that.
Oh, so it's negative 1/2. minus 1/5.
When I plug in -1 for x, what does this become?
Negative 1/5.
Again, the trick is to keep track of your negative signs. It's very, very easy to make a mistake here.
Right.
So always start from the inside and go out. Be very careful about taking that negative and turning it into a positive immediately. Let's start with that, and then let's figure out what this is, and then go from there.
Okay, so that's, if you plug in the negatives,
That's the next line. Now what's
So that
minus
is-
1/2 plus 1/5?
So that's, yeah, so that's negative 5/10, so plus 2/10, so 3/10?
Negative 3/10.
Right.
Because the negative 1/2 is a bigger number. 1/2 is bigger than 1/5. So if I have negative 1/5 and I add it, excuse me, if I have negative 1/2 added to 1/5, I better get a negative number.
Right.
Still have that negative sign out there.
Right.
So the final answer,
3/10?
and it's a positive number, which it has to be. If somehow I came up with minus 3/10, I wouldn't start all over again. I would just say it's plus 3/10. That's not always going to work, but that'll work on most of the ones you're doing.
Okay.
Okay? It's better to obviously keep track of your negative signs, but notice how many we have. 1, 2, 3, 4, 5. And sometimes if you're doing integration by parts, where there's 3 iterations, you have a UV minus something, and that turns into another UV minus something, and that turns into another UV minus something. So these negative signs can be a bear to keep straight. And the only way to do it is always start from the inside and just use lots of brackets, parentheses, and everything else. But notice that if you got a couple of the negative signs messed up, you wouldn't be able to do that little trick. In other words, if you didn't treat this properly, you wouldn't come up with the number 3/10.
Okay.
Let's see, what time is it? 6:51. We started at about 5:45.
I think we're at a good stopping point. My dad just got home, so I think my mom's going to want to eat pretty soon.
Okay, sounds good. We did an hour and 10 minutes yesterday, an hour and 5 minutes tonight. You want to schedule something else?
Not for now, I think, because just
Okay.
got my exam tomorrow. After that, I'll be done with this class.
Okay. So I'll go ahead and send you an envoice. Let's see, we should be able to do it real quick here. Let's see, this was an hour and a half. So we have 1 hour and 30 minutes, 1 hour and 10 minutes, and 1 hour and 5 minutes. That looks like 3 hours and 45 minutes. 3 3/4 times 32.
Okay.
That's what the tab is at the moment. And I will send an envoice to your email address whenever I get around to it. I don't know if I'll do it tonight, but I'll do it by tomorrow.
Okay.
Okay?
Oh, awesome.
Well, Robert, good luck on your test. I hope I've been of some help to you.
Yes, you have been. Thank you very, very much.
You're welcome. Good luck to you.
Okay, have a nice day.
You too.
Bye.
Bye.